Bismillahirrahmanirrahim. This is our lecture number 22, chapter number 2 about differentiation, and the today's topic is derivation of exponential function and the hyperbolic function. And the same exercise 2.6, we are doing this exercise. Now you can see the derivative of hyperbolic function. Better kindly open your books and see at page number 85, in which the topic is given the derivative of hyperbolic function. The hyperbolic function is defined as whenever we have hyperbolic functions are the six hyperbolic functions we have: sine, cos, tangent, cotangent, secant, cosecant. These all are the hyperbolic functions. Here we have the first example is hyperbolic function of sine hyperbolic function, in which we have exponential of x minus exponential of minus x divided by 2. This is the formula of sine hyperbolic function in terms of this exponent terms. And the domain is real number. This is the cos hyperbolic function, in which the sine and the cos, the difference of these two functions. In sine function we have this minus sign, and in cos hyperbolic function we have this plus sign. And then tan hyperbolic function, we can derive this function from sine and cos hyperbolic function like this. And then we know that the cosecant hyperbolic function is the inverse function, reciprocal function of this sine hyperbolic function. So when we convert the sine hyperbolic x into 1 by sine hyperbolic x of x, its value will also be converted. So 2 divided by exponential of minus 2 minus exponential power minus x. The same thing happened with the secant hyperbolic of x, and then we know that the cot hyperbolic of x is a combination of this secant and cosecant. So by using its value, we have this formula for cotangent hyperbolic of x. Now the derivative. Now directly, how can we find the derivative of all these hyperbolic functions? So the first, these are the six formulas. So kindly you just keep all you just keep all these formulas in your memory, in your current memory. So d by dx of sine hyperbolic of x is the cos hyperbolic of x, and the cos hyperbolic of x is sine hyperbolic of x. Similarly, tan hyperbolic is secant hyperbolic square hyperbolic of x, and the rest of formula you can see on your screen. Now we start the proofs of all these functions. I will solve one, two proof, and the rest of proof you will do it by yourself. Now I will start it from d by dx of sine hyperbolic of x. You can see it's true that d by dx of, I will write, instead of sine hyperbolic of x, I have written its formula. The formula is exponential of x minus exponential of minus of x divided by 2. The rest of question is the same, because you know that how to differentiate this exponent function. I will write it like over here. Now when we have the d by dx of, means if you have y is equals to sine hyperbolic of x, and you can write it like exponential of x minus exponential of minus x divided by 2. And when you apply the derivation d by dx of y, or you can may write it d by dx of sine hyperbolic of x, or you may write it d by dx of exponential of x minus exponential of minus x divided by 2. Now if 1 by 2 is a constant number, so you will write it here, and d by dx of this exponential of x minus exponential of x. So these are the two terms. So 1 by 2, and then d by dx of exponential of x minus d by dx of this exponential of minus x. And you know that the derivation, how to calculate the derivation of exponential function. So 1 by 2 exponential of the derivation of exponential function. First time we write this exponential function as it is, and then we differentiate its power minus exponential of x, again d by dx of what, sorry, its power, that is minus d by dx of minus x. Now 1 by 2 derivation of x with respect to x is 1, and minus exponential of minus x, and here again we have minus 1. So when we simplify this, we have 1 by 2 exponential of x plus exponential of minus x, and you can see this is the formula of cos hyperbolic of x. So through this derivation, here you have d by dx of sine hyperbolic of x. So you can see that derivation of sine hyperbolic of x is cos hyperbolic of x. By doing the same calculation, you can find the different formulas and different formula for all the six these hyperbolic functions. Now move to exercise in 2.6. In exercise 2.6, you have question number 3, in which you have to find dy by d. I will show you the question 3 over here. These are the different proofs. You can see all the proofs from these notes. Now derivative of inverse. So before starting the question number 3, I will tell you the derivative of these are inverse hyperbolic of function. Like simple trigonometric function, we have some inverse trigonometric functions. Definitely with the hyperbolic function, we have six inverse hyperbolic functions also. And these are the different formulas of all these inverse hyperbolic functions. Now the proof of these inverse hyperbolic function, here we have, let's say y is equals to sine hyperbolic inverse of x. So we write it like, if we bring sine hyperbolic over here, so we write it sine hyperbolic of y is equals to x. And when we start differentiation, we have d by dx of sine hyperbolic of y is equals to d by dx of this x. And we know that the derivation of sine hyperbolic of y is cos hyperbolic of y. And because the variables are different, so we have to write here dy by dx is equals to 1. I will explain it over here. Like if we have, I'm saying that if we have y is equals to sine hyperbolic inverse of x. So if I write it like sine hyperbolic of x, sine hyperbolic of y is equals to sine hyperbolic of y is equals to x, and then if we differentiate both sides, d by dx of sine hyperbolic of y is equals to d by dx of this x, right? Now I will apply the derivation rule. I know that the derivation of sine hyperbolic of y is cos hyperbolic of y. Okay, then I have written here cos hyperbolic of y. Then I have to differentiate is angle. Its angle is what? Here we have y. Here we have this y in its angle. Sine hyperbolic is a function. Y is a separate variable, right? So what we do, we will write it like this, and then here we have dx by dx is equals to 1. So cos hyperbolic of y is equals to, dy by dx is equals to this 1. But you know that we need to find dy by dx, means cos of y is extra term. So dy by dx is equals to 1 by cos hyperbolic of y. As you can see it here, dy by dx is equals to 1 divided by cos hyperbolic of y. Now cos hyperbolic of y is equals to, you know that the formula, that is 1 divided by, sine sine hyperbolic square of x plus cos hyperbolic minus, that is what I am going to confirm. Cos hyperbolic square of x minus sine hyperbolic square of x is equals to 1. In hyperbolic case, we have 1 over here, minus over here. So if we find cos hyperbolic square of x is equals to 1 plus sine hyperbolic square of x, and when we take under root for finding the value of cos hyperbolic of x, I have 1 plus sine hyperbolic square of x. So I can write here dy by dx is equals to 1 divided by 1 plus sine hyperbolic square of x, right? So the next step is, here we have written 1 divided by 1 plus sine square hyperbolic, and we know that the value of sine square of x is equals to what? Sine square of sine hyperbolic of y is equals to this x. So we can write here, what we can write here? We can write, instead of this sine hyperbolic, we can write it x square. Sorry, here I have written all this formula for x. You may convert it for y. Cos hyperbolic square of y is equals to 1 plus sine hyperbolic square of y, and then when you find its value, 1 plus sine hyperbolic square of y. So here we have this y, and you can see the value of sine hyperbolic square of y from our question. You can see this is equals to sine hyperbolic of y is equals to x. So we can write here dy by dx is equals to dy by dx is equals to 1 divided 1 plus x square under root. So this is the derivation of its first formula. You can do it for cos hyperbolic square of x, cos hyperbolic inverse of x, and so on. Here in these notes we have y is equals to cot hyperbolic inverse of x, then y is equals to secant hyperbolic inverse of x, and the rest of solution you can solve it by yourself. Now we are going to move on question number 3, in which we have to find the derivative when y is equals to cos hyperbolic of 2x. Now you can, okay, I will solve it for you. Question number 3. Question number 3, its first part. I will solve the first part for you. That is, y is equals to cos hyperbolic 2x. It's a very simple question. We apply derivative on both sides with respect to x. So d by dx of cos hyperbolic 2x. So you know that the derivation of cos hyperbolic 2x is sine hyperbolic 2x, and then the derivative of its angle. And when you simplify this, you will get 2 into sine hyperbolic of 2x is the answer of your question. Now the second part. Now move to second part of your question. The second part is y is equals to uh, sine hyperbolic of 3x. You can solve it by yourself. It's a very simple part. Then y is equals to tan hyperbolic inverse of sine of x. So no need to confuse in this question, because this question is looking very difficult, but actually it's a very simple question. But just you keep in your mind that you remember all the formulas that I have mentioned you before my this lecture. So you know that d by dx of tan hyperbolic inverse of x is equals to 1 minus x square. So by using the same thing, here we have x, but now in this case we have sine of x. So we can write it 1 divided by 1 minus x square. Here we have x, so we have x square. But here we have sine, so sine of x. So we write sine of x whole square, right? And then derivative of this sine of x means angle of this hyperbolic function. So 1 by 1 minus sine square of x into cos of x. So this is the mm, sine square of x into cos of x. So if you write the formula 1 by cos square of x into cos of x, when you cancel all these, you get 1 by cos of x equals to secant of x. So this is the solution. And then we have the fourth part. The fourth part is also very simple. The fourth part, in which you have y is equals to sine hyperbolic inverse of x cube. This is also value. You differentiate both sides with respect to x, and d by dx of sine hyperbolic inverse of x cube. You know that you have here, you will use the formula when you have sine hyperbolic of hyperbolic inverse of x, you have the formula 1 divided by 1 plus x cube. But in this case you have this x cube, so 1 divided by 1 plus x cube square, whatever you have there, but you will move according to the formula. Here you have x, you will write it x square. Here you have x cube, you will write here x cube whole square, right? And then obviously the derivative of its angle. Now 1 divided by 1 plus x power 6 into 3x square. I have used here the power rule. And this is the answer of our question. 1 plus x power 6. Okay. Now these are the solutions of all questions. The last question, one more question I will solve here for you, and that is this fifth part, in which we have y is equals to log of tan hyperbolic of x. So d by dx of y is equals to 1 by tan hyperbolic. You know that whenever you have this natural log, you will write 1 by this argument and then derivation of this tan hyperbolic of x, and 1 divided by tan hyperbolic of x, and then you know that the derivation of tan hyperbolic of x is secant hyperbolic square of x. The rest of calculations are the simplification of this part, and if I write this sine hyperbolic, instead of this I will write it cos hyperbolic of x divided by sine hyperbolic of x into 1 by cos hyperbolic square of x. This will be cancelled with this, and I will get sine hyperbolic of x into cos hyperbolic of x. And this is the answer of our question. Now these are the solution of all the question number 3, all parts of question number 3, and if you have any problem you can contact